Ciao friends, and welcome to a new Unplugged video from SQL BI. Typically in Unplugged videos, what we do is create a solution or work on a formula or solve some problems together. This video is kind of different because what I'm going to do is just exploration of possible techniques for an article. Let me give you a bit of background first. I am about to write an article on how to show 0 instead of blank in a measure that would return blank, but we want it to return 0 instead. Now, it's an article that I need to write, and the work that we do every time we write an article is to investigate on possible solutions, because people later will use our code, and so we need to make sure that it's fast, it's efficient, and if there are possible solutions, we investigate at least the ones that come to our mind before writing the article itself. So the goal of this video is to investigate on possible solutions. I have some ideas in mind about how to solve the scenario and how to speed it up, but I'm totally not sure that any of the ideas that I have will actually work. So what is going to happen is that we will write quite a lot of DAX code together, and most of it will be rubbish. We will just throw it away because it's a test, it doesn't work, so it's not worth working on it anymore. With that said, to me, an important part of our job is knowing what works and what does not work and the reason why it doesn't work. So it might be useful to look at the entire process of searching for the best solution. Then after the Unplugged video is finished, then it will be time to write the article, and I will also record a video specifically about the article. But that video will be much cleaner. I will just show the best solution we found with some considerations. Here in the Unplugged, I just show the entire process of thinking about the possible solution. Let's get started. Let's start by understanding the scenario that we are working on. I read on multiple articles on questions on our forums, people that want to display 0 instead of a blank when the value of the measure is actually a blank. There are multiple reasons for that. Mostly because you do want to see, for example, countries with no sales, even when there are no sales at all. But you want to see the country and you want to see the value 0. The same for dates or for specific products. It is important to know that a product did not produce any sales, which is different than not seeing the product at all. I want to see the product and I want to see 0. That means I didn't sell any of those products on that specific date, in that specific country, or in whatever condition. The problem is most DAX measures, if there are no data, they just return a blank, and therefore in the report they will disappear. Let's see that with an example. I'm showing here, sliced by country and year, the value of the sales amount. Now, for 2007, we have a value for all of the countries, but look at 2008. Japan in 2008 did not produce any sales. The same for China, India, Russia, and so on. This is not a big problem because I still see Japan and I see sales in 2007, 2008, no sales, and then I see in 2009. But the reason why I'm seeing Japan is because I have sales in 2007 and 2009. If I filter only 2008, you see that Japan disappears from my list, because it no longer produces any result. The value of sales amount for Japan in 2008 is a blank, and as such, it disappears from the list. This is not a big problem as long as I'm using matrix, but if I start using charts, it's a bit more annoying, because if I slice 2009, you see that I have a list of countries here, which is unreadable, but it's not important to read it. Just look at the number of countries that I have. And if I click on 2008, the number is highly reduced. So I no longer see all the countries that did not produce any sales. I want to return 0 instead of a blank, so that it will show the value, showing a 0. So I will have the name of the country, I will see no value, so just a 0, but I want to see the country even though there are no sales at all. Now, there is a very quick solution to this, which is adding a 0. I can just go here, take my sales amount, and let me increase the font a bit so we can read it, and say that sales amount is my expression plus 0. Now, if the first part of the expression returns a blank, blanks plus 0 is 0, and that will return a number. If I do that, you see that now Japan appeared. It's here. I have my Japan with the value of 0. The problem is that this is adding too many zeros to the entire report. If I get rid of the filter on the year, you see that suddenly I have 2005, 2006, then I have 2007, 8, 9, which I want, but I also have 2010 and 2011, because there the value of my measure is now 0. It's no longer a blank, and so it's there. I need to get rid of that, and this creates the first question that we need to answer. How do I decide when to show a 0 and when not to show at all a measure? This is typically the beginning of endless discussions with your users in order to understand what is the difference between 0 sales and no sales. Looks like it's the same concept, but it raises a lot of discussions. Most of the times, nonetheless, the measure or the dimensions that we use for that is time. So if in that period of time there were sales for any product, then we consider that as a valid period in time. And if there are no sales for a product in a period in time where other products sold something, then I want to report it as 0 sales. Whereas if no product sold anything in a given period in time, even though I have the row in the date table, then I want to show blank everywhere, because that is a non-existent piece of information. So we could use time, and we could change the sales amount to reflect that. So let's do that. But instead of, let's go there. Instead of working on sales amount, let's build a new measure, because so we keep sales amount as it is. Let's call it sales amount 0. As I said, we want to show a 0 if there are sales in that period in time for any other product. That means we need to retrieve the first sale ever, the last sale ever, and any date in between the first and the last sale need to show a 0. So we need first the first sale ever, which is just calculate the minimum of sales order date. I exceed it a bit, and then we remove any filter. That returns the first sale ever. Then we also need the last sale ever, which is the same expression, but now we retrieve the maximum sales. Then we need the current date, which is, let's take the maximum of date. And then we need to check whether the current date happens to be in between the first and the last sale. So force 0. That checks that the first sale ever is less or equal than the current date. And at the same time, the current date is less or equal than the last sale ever. And then the amount, which is sales amount, actually we can do amount is sales amount plus if force 0, 0. And then we return amount. So we compute the sales amount, and then if force 0 is true, meaning that the date happens to be in between the boundaries, then we add 0. Adding 0 if the first part of the sum returns a blank, blank plus 0 equals 0. That should already work. Let me just format it as a decimal. And then we get rid of this, we get rid of sales amount, and we place sales amount 0. Now that is much better. You see that we have 2007, 2008, 2009. We do no longer have the previous years, and we have zeros for Japan. If I only select 2008, I still see 0, which is exactly what I wanted. Now, it looks like the problem is solved, and actually it is. That is already working. But the next step that I want to do, and I plan to publish in the article, is to show how to do the same operation not only for sales amount, but for any measure. So what I want to do is create a calculation group that applies the same calculation that I'm doing right now in a measure, but it does it for any measure. That calculation group then will be filtered accordingly to what you want to obtain. Because it's a calculation group, people are likely to use it widely. So I want to evaluate the price that I have to pay to add this logic to my measure and check if there are better ways of obtaining the same goal. Because despite being nice, the solution we have right now just works considering the dates. But you might want to have more complex considerations. Picture, for example, this. I have a product which has been introduced in the market at a given point in time. So it has not always been available. Before that product was available, I do not want to show the product with 0, because it was not available at all. After its introduction to the market, if there are no sales, then I want to show the value. This requires further logic, so that would be much more complex, and maybe this code is already too slow. So we need to, first of all, evaluate the price of sales amount 0 compared with a bare sales amount. To do that, we need DAX Studio. Here it is. So we need to, first of all, evaluate performance. Let me run a query like evaluate summarize columns by date, and we create amount, which is just sales amount. If I only use date, that is not probably gonna be slow enough. Let's also add the country region, customer country region. Amount, we enable server timings, and we run it. That is gonna be very fast. Let's look at the server timings. Yeah, 28 milliseconds is the time required to compute just sales amount. What about sales amount with 0? That includes further logic, so it's probably gonna be slower, and it is indeed. 65 milliseconds instead of 28, so it's doubling the time required to compute the expression. Most of the time is Formula Engine, exactly as expected, because it needs to add this further logic of checking whether the dates is in between the two boundaries. So it works, and it works just fine, but we need to take into account that adding this logic slows down the calculation. I'm working right now with the 12 million row version of Contoso. There is another opportunity, another idea that I have in mind, which is using a table to store the information about whether I want to show a date or not, because that gives me more flexibility. Right now, the calculation about whether I want to show 0 or not uses the two dates and check if the date is in between the boundaries. But what if I create a table that only contains the dates for which I want to show values which are not 0? And then I use that table in order to check if I want or not to show the result. This has an additional benefit, that is, if I can store the logic about whether I want to show 0 or not in a table, I can make it data-driven in a better way. For example, I can store in the table not only the date, but also the product. So I have the combination of product, date for all the combinations where I want to show the value. This gives me the flexibility that if I want to start showing the value of a given product from one point in time, I will embed this logic in the table. So I avoid having complex tax code and everything is in the table. The thing is, I don't know the size of this table, that is going to be the cross join of product and data, so potentially a large table. And I have no idea about performance. Therefore, we need to test it. To do that, we need to create the table. As I said, the table needs to be the cross join of products and dates. So let's go for not new column, but new table. And we call it, how do we call it? Zero grain. That is the granularity at which I want to show 0. Right now, zero grain looks like the name for some organic food, but let's pretend that it's the name of a table. So it's a cross join of all noble and crow. We want the dates of date, and all noble and crow of product. The reason I'm using all noble and crow obviously is because I don't want circular dependencies. So let's first run it. Okay. Now we do have the table that is 6 million rows. Actually, I'm not interested in date. I made it wrong. I don't want all the values in date. I want the values in sales order date. So that should be sales order date. Okay, 2.7 million rows. And now I have my zero grain table. That said, I need to change the code, but I will do that directly in DAX Studio because it's probably easier. Let me define the measure here. Now I need a new measure. Let's call it sales amount zero grain. That computes, that needs to check if there are values in the table. And I missed an important point because now I have the table, but I didn't create any relationship. I have my zero grain table here that is not linked to anything. I want zero grain to be linked to date and to product. So that when I filter date, order date goes to date. When I place a filter on date, I'm filtering zero grain. What happened to my product table here? And while we're here, we also do the same for the product key. Pin at the top. So a filter on the date will filter the zero grain table. A filter on product filters zero grain, and I only need to check if there are rows in zero grain, I add a 0. Otherwise, I avoid doing that. Let's go back here. So sales amount greater than 0 should check if count rows of zero grain is greater than 0. That means there are rows there. Then compute sales amount plus 0. If the count rows of zero grain is 0 that means we do not need to show anything, and it's pointless to compute sales amount at all because there will be no sales. So we need to remember 65 milliseconds is the time, let's call it baseline. 65 milliseconds. Let me get some space. Okay, also this is useless. So instead of computing sales amount 0, now we call sales amount 0 grain. Let's see how it goes. Well, not that bad. At 75 milliseconds instead of 63, instead of 65. So we only added 10 milliseconds, but we are gaining quite a lot because we have a lot more flexibility if we use this solution. But I didn't check the size of this table. Let me go and look at how large this table is. Where are you? View matrix. Okay, I have 12 million rows in the sales table that is using, what happened here? Let me do that again, view matrix, so it refreshes everything. Okay, 12 million rows in sales, 173 megabytes the size. 0 grain is 4.5 megabytes, so it's not that large. Could have been much worse than that. And performance-wise, it's not bad. It's a bit slower than the previous one, but I have a lot more flexibility because of this. What happens if I use if eager instead of if? So to force the calculation in any case. Oh, hello, that's a bit better. Not that faster, but a bit faster. Let me run it a couple of times. 63, 62. It's quite consistent. Using if eager, I'm basically forcing the calculation all the time because this is a very dense calculation, so it makes a lot of sense to use if eager instead of a regular if. So that is a good solution. Sales amount 0 grain equals 62 milliseconds. Because that gave me the opportunity of storing in a table the logic on whether I want or not to show a 0 and avoid the complex logic in the DAX formula. So right now my calculation, my 0 grain table is just a cross join, but I can make it much more complex, taking into account the date where I introduce products or the dates where I start selling in a given country and so on. So that the flexibility that I gain is quite a lot. I still have a few tests that I want to do. Right now I'm using count rows 0 grain greater than 0. What if I use not is empty 0 grain? That might be slower or faster, I don't know. It's actually the very same. Time-wise, it's the same. We have 3 storage engine queries here. And if I go back to count rows greater than 0, we still have the same storage engine query. So it's basically the same. Using count rows or using is empty produces the very same calculation. But what can I get rid of the if entirely? That I don't know. What I would like to do is remove this, not this if entirely. Now, when count rows 0 grain is greater than 0, that returns true. If it returns true, I want to add 0. If it returns false, I want to return blank. Now, I'm gonna do something really dirty, but it's worth a try. I try to write a Boolean expression that evaluates to 0 or blank, depending on count rows of 0 grain, but it does not use the if statement. And I'm gonna use divide to do that. Instead of doing count rows of, no, I keep this. I get rid of if, and I divide 0 by this. Now, when count rows of 0 grain greater than 0 is true, this is 0 divided true, so 0 divided 1, that is 0. But when count rows of 0 grain greater than 0 is false, this divides 0 by 0, that results in a blank, and that will be sales amount plus blank. So despite being totally unreadable, this should work, but I don't know if it's gonna be faster or slower. It's nearly the same, but looks like I have one more storage engine query now. I have 4 storage engine queries now. I need to remember to save my code. So let me go back. Now let me copy this in the clipboard. Let me go back to the previous version. This generates 3 storage engine queries, yes. The one that looked smarter, it is actually not, because if I use the next one and I run it, I will now find 4 storage engine queries. So there is one more. Therefore, this version that looked very bright just because it's more intricate, it's actually worse. So that is not a bad solution. Count rows of 0 grain greater than 0. It requires creating a table, but it is the same speed as the previous one, and it has a lot more flexibility. What if I don't want to create a new table? Well, if I don't want to create a new table and the only thing that matters to me is the date, I could store a column in date. I could create a column in date that contains 0 or blank. It contains 0 if it is in between the dates with sales, and it contains blanks otherwise. So I can sum that value, I can sum the value from the sales table, and that results either in 0 or blank, and I add it to sales amount. That only requires one calculated column in date. So again, it might be better or worse. Let me try that. We can go in date, create a new column, but before creating a new column, let me copy the code from here, because most of the logic is already here. So let me build a new column. And we call it 0 grain again. Now it's a column, it's not a table. I don't need this stuff because I don't have a filter context. I don't need this. That only needs to be date because we do have a row context. Force 0 is the same, but then we say if force 0, then 0. That column 0 grain should be blank in 2006, then at some point start to be 0, and then again it's blank. Looks like there are not enough rows. Maybe it's not sorted. Sort ascending. Of course, if I don't see the column, it's useless. 0, now it's blank, then it starts to be 0 at some point. And then, no, it's 0 for a long period until I reach 2010, where I no longer have sales. Now that I have this column, I can go to my code and try a different version. This is the best so far, so let's keep it. I know there is a command to comment automatically, but I never remember that. What I can do is compute sales amount plus the sum of date 0 grain. Now, this part of the expression will be either 0 or blank. If at least one data with 0 appears in the filter context, for the date table, that is going to be 0, and I will show the value even though there are no sales. Let's give it a try. Crash. The syntax is define measure. What is that you don't like? Maybe just that you need this. Yes. 63 milliseconds. 3 storage engine queries still, and it's the same speed as all the other ones. The advantage is that this solution requires only one column in the table instead of requiring an entire table. The drawback is the same we had earlier. It's less flexible. I can just create one column, but if a product starts selling at a given point in time, I cannot store this information. So far, I still like the solution with the entire table. That was large, but not that bad. And I want to investigate a bit more on this solution because see what I did. I created the table with order date and product key. And the table is 2.7 million rows. What if I don't want the individual dates? So what happens if I say, well, I want the grain to be set at the month level instead of at the day level? That will reduce quite a lot, by 1/30 the number of rows in the table. So I store one row per month instead of storing one row per day. That looks promising, but if I do that, I will no longer be able to keep this relationship, because at that point I will have the month here. So I will need to go for a many-to-many relationship. Anyway, I mean, the only way to make a decision is to test it. So let's play with that. We need to go to the table, my 0 grain table, and instead of taking the order date, I want the date calendar year month number that contains the year and the month number. The problem is that I don't want all no blank row date, because that contains also the months for which I don't have sales, so that need to become a summarize of sales by calendar year month number. So we start with 2.7 million rows and we go to 90,000 rows. That is way better. That only contains 90,000 rows. The relationship is no longer active. It's no longer there at all because I killed the column. But I can create a relationship between calendar year month number and calendar year month number. It's a many-to-many, of course, and I want the date to filter 0 grain, and I want the relationship to be active. So now date filters 0 grain, And that should be the very same with the detail that now I'm working at the month level instead of at the day level. And I'm using a many-to-many relationship, a many-to-many cross-filter relationship, or a weak relationship, call it the way you like it. These relationships are inherently slower than the other table. Let's give it a try. I need to go to DAX Studio. And actually, the code is the same that I had here, because I changed the model, but I didn't change the logic. I still count the 0 grain, and I return sales amount plus 0 if there are rows. The thing is that the size of 0 grain is now going to be smaller. Let's give it a try. Oh, that is cool. Well, kind of, because it's still 65 milliseconds, so speed-wise it's still good, but I have increased the number of storage engine queries. At the same time, if I look at the matrix, the table that was 2.7 million rows, that is 4.5 megabytes, if I refresh the matrix, now the same table is 90,000 rows, 243 kilobytes, so it's much, much smaller. And again, that comes with pros and cons. So reducing the number of rows in the table obtains a benefit in terms of speed, which you pay later when you need to traverse the many-to-many relationship to find the values in 0 grain. So it's a balance. I'm totally not sure about which of the two to choose. But I like the fact that with the solution that uses the many-to-many cross-filter relationship, you can reduce the size of the table. That opens up possibilities of implementing this solution also in scenarios where it is not so, the table would be too large to be acceptable. That sounds good. So I don't know which one to choose among the many, but the one that I like the most actually is the one that I use the physical relationship with date. So let's restore that one. We go here and we use all no blank row, sales order date. And then we rebuild the physical relationship, because my hope is to move something more on the storage engine. Okay, relationship is in place. Let's check that it still runs as earlier. Server timings, yes, still same speed, still same number of storage engine queries. So I think we found the solution that we like the most. In the article, I will probably present both solutions. The one just based on DAX, that is more DAX-like, more DAX-ish, but requires more logic if you want to introduce further complexity, and the one with the 0 grain table in the middle, because it's not slower. It adds a table that is a bit larger, but can be reduced with the technique of using the many-to-many. And speed-wise, they are good. Now, the last step, we need to create a calculation group to finish it properly. So what I wanted to do is create the calculation group, because we also need to take into account that calculation group by itself might introduce further problems in terms of speed. Let me go and define here. Let's get rid of these, yes, and we use this version of the code. I just want to check that it actually returns a good value, and it does. It works fine. If I filter only 1 year, it shows my 0. If I don't filter any year, it shows everything, and it shows the values exactly as I like. Last step, as I said, a calculation group. To do that, we need Tableau Editor. And here we go. Let's create a new calculation group that we call blanks as 0. The column name, again, blank, just blank as 0, and also this just blank. And then we create a new calculation item. Let's call it value. That is just a selected measure. And then we create a new calculation item that we call show blanks as 0. Okay, I still have the code here, so let me copy it, then go back here. And the difference is that here, instead of sales amount, I need to use selected measure. So if there are rows in 0 grain, then return the selected measure, otherwise selected measure plus 0, otherwise just don't do anything. We need to save that, go to Power BI Desktop. That did not refresh anything. I need to save this, go here, it doesn't work. Why not? Well, that happens from time to time. I have my table. I probably need to save this and open it again. I hate it when it happens, but sometimes it still happens that the connection between Tableau Editor and Power BI Desktop does not work as expected. Actually, I have my blank as 0 here, so I can now get rid of the measure sales amount. I put again sales amount, and now it's showing the values. I have my calculation group blank as 0, and we use it as a filter on the visual. If I click show blanks as 0, it's beautiful. It now shows the blanks as 0. If I get rid of that, it just shows blanks. So it works, but what I wanted to do is to check the impact on performance. So I need to go back to DAX Studio, get rid of everything here, just keep the baseline. If I compute sales amount, I run it. This is likely gonna crash because I closed the Power BI Desktop. Indeed, I need to go back and connect again. Connect to blank as 0, do that, run it, it runs, enable server timings. Okay, we run it, and now we have the server timings, it's still 29 milliseconds. What happens if we add the filter? So we do a treat as, how did I call it, as blank as 0. As blank as 0, blank as 0. This treat as basically applies the calculation item. And it doesn't work. Why not? Because blank as 0 refers to a non-existing calculation item. What am I missing? Oh, what is the value of blank as 0? That I don't remember. Let me go there. Blank as 0, show blanks as 0. Okay. Show blanks are 0. Okay. And it is 65 milliseconds. That is super cool. Because that means that this specific calculation item does not introduce further slowness compared with the base measure. But the advantage is that now that should work on any measure. So I can get rid of sales amount, put, for example, the cost amount. And again, it shows 0 if I use it, and it shows blanks if I don't. So as a calculation group, now it works with any measure, provided that it is a numeric measure. If the measure, for whatever reason, returns a string, of course, this will add a totally useless 0 at the end. But it's pretty cool. So let's do a recap, because I think we already saw enough about all this stuff. What I did was basically investigating on a problem. The main goal was to build this calculation group, because that was the idea. And you have seen that a simple problem like showing zeros instead of blanks already offers you a lot of opportunities to investigate on the code. We could write everything in DAX inside the measure or inside the calculation group. It's not that I don't like relying on DAX. It works just fine, but it forces you to build what might be a complex logic in the DAX code. Whenever the logic is simple, DAX is fine, but if the logic is rather complex, then it is probably better to create the logic in tables and use tables to drive your calculations in DAX. Then we tested the version with the zero grain table. That gives a lot of flexibility. You can make this table as complex as you want, so that is the part that I like the most. And you can make it rely on either a physical relationship with data or a many-to-many cross-filter relationship on a lower grain. You have either a large table or a small table, and again, that depends on what you need to do or the requirement that you have. We also tested the calculated column in data. That didn't give us the benefit that I was expecting. I was honestly hoping a bit better there, but it didn't work. And because it didn't work, I would prefer to have the zero grain table, because that again gives me more flexibility with the same speed. So there's no point in creating a calculated column in date, unless you are a big fan of calculated columns and you don't want to create additional table only for the purpose of speeding up calculation and obtaining more flexibility. Now that I have a clear picture about what to write, the next step is taking the solution, cleaning the code up a bit, writing the article, and then I will also record the video about the solution. Of course, in the video, I will not show the entire process that led me to choose one solution against the other ones. I will just tell you, hey, this is a cool solution, just implement it this way. You have 1, 2, 3 options, go for the one that you like the most. I hope you liked the Unplugged. As any Unplugged, it does have a clear direction. It just shows the way we think at possible solution and the way we investigate on what is the best option for a given scenario. Enjoy DAX!